Marcus, and this is Meng. Today we'll be talking about chemical reactions, and we are representative of Augsburg Academy. Let's go!
Okay.
Our first experiment will be doing the rate of reaction. Take it away, Ken.
So we're going to need 2 measuring cylinders, 2 conical flasks, a thermometer, 2 test tubes, 3 beakers, a stopwatch, 1 piece of paper, a pencil, sodium thiosulfate, and hydrochloric acid. So first, we're going to put the cross on the paper. Like that. Next, we put a conical flask on top of the cross. Next, pour hot water into a beaker.
This is actually going to be very hot.
Next, we take 15 ml of sodium thiosulfate and pour it into the measuring cylinder.
Then put it into the test tube. Next, put it into the bath. And let it soak for 5 minutes.
Next, we pour 10 ml HCl into the measuring cylinder. Please do not take the same measuring cylinder.
Repeat this and put it into the test tube. Put it in the bath tube. Let it simmer for 5 minutes.
I think now we can add.
After letting it simmer for 5 minutes, we take the 2 test tubes and pour the sodium thiosulfate into the conical flask, then the hydrochloric acid.
Then take the temperature. The temperature is, as you can see, the solution has now turned milky, cloudy. Meng will now explain to you why this has happened.
So this is the chemical reaction we used. It's sodium thiosulfate plus hydrochloric acid. It will produce sodium chloride, water, sulfur dioxide, and sulfur. The sulfur makes the solution seem milky.
After completing this experiment with hot water, repeat this experiment with cold water instead. The reaction should take longer as reaction is affected by the temperature.
Hey Marcus, I have a question for you.
What is it?
Why do you think the chemical reaction occurs faster in hot water?
Oh, that's simple. Because the rate of reaction is directly proportional to the temperature. Therefore, when you use hot water, the reaction will be faster. Yes! For our second experiment, we'll be doing the classic lava lamp. Have you ever thought the lava lamp was actually old school? Well, let's bring it back to life.
So we're going to need oil, a container, red food coloring, and aspirin, which is also vitamin C.
Yes. First,
we pour the oil into the container.
fill about 2/3 of the thing.
Parents are gonna love it.
Huh?
That's 2/3.
I know, I'm fighting.
Okay, that's 2/3.
Next, fill a bit of it with water. After adding water, you should let it settle for a while.
So after letting it settle, we put in the red food coloring. Only add a few drops. Then let it settle for a while.
Let it settle for a while, people. Finally, add aspirin. They go down. It's fizzing!
Yo! It worked for once.
I'm a genius.
I'm a genius!
Yes!
That doesn't look right.
Of course it doesn't.
Our first. Oh, yes, that looks right.
Holy.
But then at least it's good.
Focus, people, focus. For our third experiment, we'll be doing the classic volcano. Kenny will now tell you what materials you will need to do it.
So we're going to need
How do you calculate? For our third experiment, we'll be doing the classic volcano. Now Kenny will tell you what in the For our third experiment, we'll be doing the classic volcano. Oh my goodness. For our third experiment, we'll be doing the classic volcano. Kenny will now brief you in what materials you will need.
So we're going to need baking soda, vinegar, red and yellow food coloring, a beaker, and a spatula.
For the container of
So first, we put in 2 spoonfuls of baking soda into the beaker.
I'll start.
Okay, cut this part.
Help us idea.
So what you do? Next, we put in a few drops of both red and yellow food coloring.
We forgot to open cap. Let it settle for a while. Finally, if you want to see the magic happens, add some vinegar. Watch the magic.
Okay, now more chemical reaction. Sticks.
This is how it should look like, people. You can hear the fizzing, I think.
Finally, for our fourth experiment, we'll be doing divisible ink. And Marcus will tell you the materials we need.
For this experiment, where's the beaker?
So finally, for our fourth experiment, we're going to do divisible ink. Marcus will now tell you the materials we need.
For this experiment, you will need lemon, knife, a candle, where's the lighter?
Finally, for a false
Louder,
experiment.
louder, louder.
Finally, for a false experiment,
Okay, restart.
we're going to. Yeah. Okay. Finally, for our false experiment, we're going to be doing the invisible ink. Marcus will now tell you the materials we need.
For this experiment, you will need a lemon, a knife, a lighter, a candle, a container, a cotton bud, and also a piece of paper.
First, cut the lemon in half.
Make sure there's always a parent supervising you, or you could be in deep trouble.
Next, squeeze the lemon into the beaker.
Right? Take the cotton bud and dip it into this solution.
After that, write any message you want on a piece of paper.
Make sure your hands are dry.
Because I don't know that. Jaden, give my cat.
Now, let the paper dry.
2,000 years later.
After letting it settle, it should look like this. A plain piece of paper. Now, you need to light up the candle. While you're lighting up the candle, make sure you have parental supervision. Ask your parents to do it as you might burn yourself. After lighting up the candle, put your paper over the flame and gently swish it around. Like this. You know, Ken, I've been wondering, all those experiments we did so far, what were the actual scientific explanations for those?
Well, for the lava lamp, aspirin contains citric acid and sodium bicarbonate. These two will react with each other to form sodium citrate, carbon dioxide, and water. Carbon dioxide will then try to escape the container through the surface.
What about the volcano?
So then the gas bubbles will then absorb some of the food coloring, bring it up. Then after the carbon dioxide escapes through the surface, the red food coloring will drop back down due to it being denser than oil.
What about the volcano?
Well, the volcano is similar to the lava lamp. We use vinegar, which is an acid, and sodium bicarbonate, which is an alkali. Neutralization will happen and it will produce sodium acetate, carbon dioxide, and water. The carbon dioxide will then increase the pressure in the container, making the solution in it erupt.
And finally, what about the invisible ink?
For the invisible ink, lemon contains carbon compounds. These carbon compounds are colorless in room temperature. So when there's extra heat added to it, the molecules will then break down and the carbon will be released. Then oxidation will happen which makes the carbon compounds turn light or dark brown. And when it's heated enough, it will turn black. This is the end of our video. Hope you like it and subscribe. Then I'm so tired. Ouch.
First things first, I'ma say all the words inside my head. I'm fired up and tired of the way that things have been.